In number 9, we've got 9 people, and we're choosing 5 of them to serve on a committee. And they want to know how many ways this can be done if 2 particular people refuse to serve on the committee together. Now, my favorite way to do this kind of problem is to find the total possible number of committees if there's no restrictions. And all we're going to do that is we're going to do 9 choose 5. And when we do 9 choose 5, we're going to find out that there are 126 committees. Now what we need to do is we need to find the number of committees that have both our haters on them. So we've got hater number 1 and we've got hater number 2. Now the thing is that there needs to be 5 on the committee, and we've used up 2 of our people, so now we've got 7, and we're going to choose 3 of them, which is going to give us 35 committees with the haters on them. Now all I'm going to do is subtract 126 minus 35, and we're going to find out that 91 committees will not have those haters together. All right, let's go on to the next one. In number 12, we've got a basket of 9 flowers. Now, 2 of them are pink, and 3 of them are yellow, and 4 are red. We need to pick 4 of these flowers. And then they want us to find the probability that at least 2 of them are red. All right, so first, let's talk about this. We're going to have to at least 2 red. So let's play out these different scenarios. One is I've got 2 red. That's the least I could have. And the way that could work is if I choose out of the 4 of them 2 and get red. Now the other flowers are just whatever flowers, so there's 5 of them, and I need 2 more to make my group of 4. Now if I have 3 red, well that's 4 choose 3, and then I only need 1 more out of the rest of the flowers. And if I have 4 red ones, well then I don't need any of the other flowers. So that's going to give me a total of 81 different ways that this could happen that would make me happy, where I have at least 2 red flowers. Now to find the probability, I need to know, well, how many different ways could I just make 4 flowers out of 9? And that's 126. So the probability of choosing 4 flowers out of 9 and having 2 of them at least be red is going to be 9 over 14. All right, let's take a look at the next one. All right, number 13. So let me start off by telling you I'm really sorry. This problem is terrible. Anyway, we've got 11 pieces of fruit, and they can be shared by 3 boys. Each boy has an odd number of pieces of fruit. So if we kind of lay this out, boy 1, boy 2, boy 3, well, the first thing I'm thinking is giving boy 1 the biggest amount. I'm going to give them 9. Well, that means that boy 2, if he's going to have odd, is going to be 1, and boy 3 would also have 1. So now they all have all 11. Now if I go and down 1 more, well then now this guy can have 3 and this guy can have 1, and then I can do 7 again, only give this guy 1 and this guy 3. And now I'm noticing that the third column is always going to equal 1. And I'm going to do here, I'm just going to go down systematically, and I'm going to just pick all these different odd numbers, these different configurations, and after I've got them all written down, well, what I'm going to do is I'm going to figure out what they are. And again, you'll notice in all these cases, because I'm ending up with using up all 11 pieces of fruit, the last column is always going to equal 1. So I'm really only multiplying the first two numbers. At any rate, when you do that, you'll get these. And then all you've got to do is add them up, and you'll get a grand total of 44,286. All right. Again, like I said, this is a lot, and typically you're not going to have to do this many configurations. But anyway, probably good practice. All right, let's go on to the next one. In problem number 19, it says, how many numbers are there between 100 and 999 where all 3 digits are different? All right, so let's map this out. I've got 100 to 999, but they all got to be different. 3 digits, so let's lay out our digits. Now, I've got choices of 1 through 9, because I can't start with a 0, so there's 9 possibilities. Now, the next one, I've got 9 possibilities for that, because I've already used 1 number, and I could use 0 through 9. And in the last spot, I could go ahead and use 8. Because again, I could have used 0 through 9, but I've already used up 2 numbers. I've only got 8 left. So when I multiply those together, I get 648 different numbers. Now in part 2, what they want to know is how many of those numbers are going to be odd and greater than 700. So that means we're still sticking with the same thing of 100 and 999, but 3 digits, but they could have to be odd, which means the last digit has to be one of these numbers, and it has to be greater than 700, so the first digit has to be one of these. Well, you'll notice that I've got numbers in both of my restrictions, in the front and in the back. So the only way I can do this is if I play out each scenario separately. I'm going to have to map out what happens if I use each one number. So again, for example, in this last one, if I use a 7, was only one way to do that, and now I can use an 8 or 9 in the front. There's 2 ways to do that, leaving me 8 numbers and giving me 16 possible numbers. Now, I try the next one is going to be a 9, which is one way to do that, and I could use now a 7 or an 8 in the front, that's 2, and again 8, it's another 16 possible numbers. Now, I can use 1, 3, or 5. That's 3 possible numbers. And I could use 7, 8, or 9. And that's 3 possible numbers. And I still have 8 left over in the middle. So that's going to give me 72. When I add them all together, I get 104 different possible numbers that are odd and greater than 700. Now, the last one says I've got these flowers in bunches. And we want 7 flowers. Now, they tell you that they have a bunch has to have all the flowers, and then they get really specific, and they says each bunch has to have at least 2 of each type of flower. All right, so let's go ahead and map this out. We've got roses and tulips and daffodils. We got 6 roses, and we've got 5 tulips, and we've got 4 daffodils. And let's go ahead and start with the most. So if I give this guy 3 roses, I could give him 2 tulips and then 2 daffodils. Now, there's no other way to use 3, so I'm going to use 2 roses, and that's going to enable me to give 3 tulips and 2 daffodils. And then the last possible thing is if I use 6 or 2 roses and then 2 tulips and then 3 daffodils. So that's going to give me 1,200, 900, and 600, and when I add them all up, I get 2,700 altogether. In number 20, we've got 3 identical cans of cola, and we've got 2 identical cans of green tea and 2 identical cans of orange juice. And see, in this case, I'm just going to think of them as letters. 3 C's, 2 T's, and 2 J's. They want me to arrange them in a row, so I know we're talking about permutations. And in number 1, they want the first and the last can of the row to be the same drink. Now, we've got 7 drinks, and one scenario is if I have a C on each end. Now, there's still a C left over, 2 T's and 2 J's, so that's going to be 5 factorial divided by 2 factorial times 2 factorial. Now, another way I can do this is T's on each end. Now, if I do that, well, then I'm going to have 3 C's and 2 J's, well, that's 5 factorial, 3 factorial, 2 factorial. And then the last one is if the J's are on the ends, which that's going to leave me 3 C's and 2 T's, which is going to get pretty similar to what we've done before. I'm going to have 30 and 10 and 10, giving me a total of 50 ways for that to happen. Now in part 2, the 3 cola cans have to stay next to each other, and the 2 green teas have to be apart. So we're going to think of the 3 cola cans as being one thing. Luckily, they're all the same. They're identical, so we don't have to worry about arranging them. And we're going to use stars and bars. Now, our 3 things, our bigger group is going to be the bars. And those are our 3 things, the C's and the 2 J's. Now what we've got to do is we've got to arrange the bars, and then we're going to place the T's where the stars go. So the arranging of the bars, well, that's 3 C's and 2 J's. That's going to be 3 factorial over 2 factorial. And then when I look at the stars, there's 4 of them, and I only got 2 T's. So I'm going to do 4p2, but the t's are identical, so I have to divide by the 2 factorial. And now all I got to do is multiply this together, giving me 18 total ways for this to happen. All right, hope that helped. Thanks for watching.